In this video, we're going to talk about quadratic functions in factored form. So a quadratic function in factored form is in this form here, y equals k times x minus a times x minus b, and k cannot be 0. So an example of a quadratic function in factored form might be something like this: y equals x plus 5 times x minus 2. And in this example, our k value is 1. So now, why is this called factored form? Well, it's because we know that factors are two numbers that get multiplied together. So if I say 4 times 5 equals 20, well, 4 and 5 are the factors of 20. And so we know from previous lessons that we can take this x plus 5 times x minus 2 and we can FOIL. First, outer, inner, last. So we say first x times x, that's x squared. Outer, x times negative 2 is negative 2x. Inner, 5 times x is 5x. And last, 5 times negative 2 is negative 10. And when we combine the like terms here in the middle, we get negative 2x plus 5x is 3x. So we get x squared plus 3x minus 10. And if I write this like this, y equals x squared plus 3x minus 10, this is a quadratic function in standard form. Now, this quadratic function here, y equals x squared plus 3x minus 10, is equivalent to y equals x plus 5 times x minus 2. So this is the factored form of this function, and it's the factored form because we haven't multiplied yet. X plus 5 times x minus 2 becomes x squared plus 3x minus 10. So x plus 5 and x minus 2 are the factors of x squared plus 3x minus 10. That's why this is called factored form. So why is it valuable to understand how to use quadratic functions in factored form? And the answer is because when you have a quadratic function in factored form, it's very easy to identify the x-intercepts or the zeros of a quadratic function, which we know from previous lessons are the solution to the quadratic equation. So what I'm going to do here is we're going to take this quadratic function in factored form and we're going to put it into a graphing calculator, and we're going to see how each of these factors, x plus 4 and x minus 2, are connected to the x-intercepts or the zeros of the quadratic function. So first, let's go ahead and convert this quadratic function in factored form into its standard form. And we're going to do that by FOIL. So first, x times x, that is x squared. Outer, x times negative 2, that's negative 2x. Inner, 4 times x, that's 4x. And last, 4 times negative 2, that's negative 8. Combine like terms here, negative 2x plus 4x is 2x. So we get y equals x squared plus 2x minus 8. And so here we have the factored form of the quadratic function, and here we have the quadratic function in standard form. And so one other thing that we're going to do here is we're going to take each one of these factors, x plus 4 and x minus 2, and write them as separate functions. So actually what I want to do is go back here and I want to change this y to f of x. And then so I'm now going to have here g of x equals, and I'm going to have this factor here, x plus 4. And then I'm going to have h of x equals, and I'm going to have this factor here, x minus 2. And we're going to graph these three functions so that we can see the relationship between the factors and the quadratic function here, and how the x-intercepts and the zeros are related. All right, so let's go ahead and put in these functions. First, we're going to put in the quadratic function. So f of x equals x squared plus 2x minus 8. And we see the parabola pops up right there. And we can look, and if we remember from previous lessons, we can see the solutions to the quadratic equation because we see the x-intercepts and the zeros right here. We can see that the parabola intersects the x-axis at -4, 0 and at 2, 0. And we know that the solutions are the x values, -4 and +2. So now let's go ahead and put in the other two functions. So we have g of x equals x plus 4. And there is the graph of that function. And we have h of x equals x minus 2. And there we have that function. And notice that these two linear functions, g of x equals x plus 4 and h of x equals x minus 2, intersect the x-axis in the same exact location that the parabola intersects the x-axis. So hopefully with this, we can see the connection between the factored form of a quadratic function and the standard form of a quadratic function, and how the factored form gives you the x-intercepts or the zeros. Notice here that in g of x equals x plus 4, where did the line intersect the x-axis? At -4. We had x plus 4, and the intersection point was -4. And same here for h of x equals x minus 2. We had a -2 here, but where did it intersect the x-axis? At +2. So that's a connection that we're going to see as we continue on with this. All right, so let's talk about converting quadratic functions from factored form to standard form. And you've already seen me do this twice in this video. So if we have this quadratic function in factored form, y equals 2 times x plus 1 times x minus 4, how do we convert it to standard form? Well, step 1 is we are going to FOIL, okay? So we're going to multiply x plus 1 times x minus 4. So we have x times x, first x times x, that's x squared. Then outer x times -4, that is -4x. Then inner 1 times x, that is 1x. And last 1 times -4, that's -4. And we can combine like terms here in the middle. -4x plus 1x is -3x. So I have here x squared minus 3x minus 4. But we can't forget about this k value of 2 here. We still need to take care of that. So now we need to distribute this 2. So we're going to need to multiply everything inside this parentheses by 2. So 2 times x squared, that is 2x squared. And 2 times -3x, that is -6x. And 2 times -4, that's -8. So here we have converted this quadratic function from factored form, y equals 2 times x plus 1 times x minus 4, into standard form, y equals 2x squared minus 6x minus 8. So now let's go ahead and take a look at this second example here, and I encourage you to pause and try it on your own. We have y equals 3 times x minus 5 times x minus 2. First step, we're going to FOIL. So first times first, x times x is x squared. Then outer term times outer term, x times -2, that's -2x. Inner term times inner term, -5 times x is -5x. And last term times last term, -5 times -2 is +10. And we could combine like terms here. -2x minus 5x is -7x. So we have here x squared minus 7x plus 10. And again, we cannot forget about this 3, this k value of 3. So now we need to distribute. So 3 times x squared, that is 3x squared. And 3 times -7x, that is -21x. And 3 times 10, that is 30. So here again is the quadratic function in factored form of y equals 3 times x minus 5 times x minus 2, converted to standard form, y equals 3x squared minus 21x plus 30. So when your quadratic functions are in factored form, it is very easy to identify the x-intercepts or zeros of the quadratic function, which we know are the solutions of the quadratic equation. And the reason why it's very easy is because of a property known as the zero product property. And so the zero product property, it actually makes a lot of sense. It's basically, if I tell you, if I multiply two numbers together and the answer is 0, then what do we know about at least one of those numbers? We know that at least one of those numbers is 0, because the only way you can multiply two numbers together and have an answer of 0 is if one of those numbers is 0. So that the zero product property looks like this. If A times B equals 0, then we know that either A equals 0 or B equals 0 or both of them equal 0, because 0 times 0 is 0. So we can apply that concept to solving a quadratic equation in factored form. So I see here x plus 5 times x minus 2 equals 0. So consider that x plus 5 is A and x minus 2 is B. If A times B equals 0, then what do I know? Either A equals 0 or B equals 0 or both. So we can use that, and if x plus 5 equals 0 or x minus 2 equals 0 or both, what we can do is write them as separate equations and then solve those equations. So I'm going to write one equation that says x plus 5 equals 0 and another equation that says x minus 2 equals 0. And then I just need to solve these very basic equations. So x plus 5 equals 0. In order to solve for x, I have to subtract 5 from both sides. And I get x equals negative 5. And over here in x minus 2 equals 0, in order to solve for x, I have to add 2 to both sides. And I get as my solution x equals positive 2. And so these two right here, these are the solutions, the x-intercepts, the zeros of this quadratic function. These are the solutions to this quadratic equation. Very simply done. If we had gone back to a previous lesson where we learned how to graph this, then this parabola would be intersecting the x-axis at negative 5 and positive 2. So that's how easy it is to identify the x-intercepts and zeros of a quadratic function. So let's go ahead and take a look at these examples. I see here I have y equals 2 times x plus 6 times x plus 3. And if I write this as a quadratic equation set equal to 0, that would look like this: 2 times x plus 6 times x plus 3 equals 0. And so again, if A times B equals 0, that means either A equals 0 or B equals 0 or both. So one of these equals 0, and we know it's not 2. 2 doesn't equal 0. 2 equals 2. So either x plus 6 equals 0 or x plus 3 equals 0 or both. So we set our equations. So I have here x plus 6 equals 0, and I have x plus 3 equals 0. And then I solve. So in x plus 6 equals 0, in order to solve for x, I need to subtract 6 from both sides. So I get x equals negative 6. And here in x plus 3 equals 0, in order to solve for x, I need to subtract 3 from both sides. Actually, there we go. And we get x equals negative 3. So now there's a pattern that you may have noticed that I showed you when we did the example on the graphing calculator, and you might see it here. Notice we had x plus 6, and what was the solution? X equals negative 6. And here we had x plus 3, and what was the solution? X equals negative 3. So you can see they're opposites, and if you think about it, it makes sense, because in order to turn a 6 into a 0, you need the opposite, right? 6 plus negative 6 equals 0. So that is a quick little trick that you can use to actually get to the x-intercept of the 0 even faster if you pay attention to the fact that they are opposites. So if I look here at this second example, I have y equals negative 2 times x plus 4 times x minus 5. And I could kind of skip this step if I understand what's going on. I know that I'm going to end up with the equations x plus 4 equals 0 and x minus 5 equals 0. But if I even understand the concept of opposites, I could just look here and say, well, what's the opposite of positive 4? Negative 4. So x equals negative 4. And the opposite of negative 5 is positive 5. So x equals positive 5. And those are the x-intercepts, or the zeros, of this quadratic function. All right, so one last thing here in this video. Let's talk about writing quadratic functions in standard form given the x-intercepts, okay? So unlike what we did before, they're not giving us the factors of the binomials. And then we're just going to FOIL and get our function in standard form. They're just telling us what the x-intercepts are. And really, this is just one more step. So in this example here, the x-intercepts are 2 and 5. So if I remember what the x-intercepts are, what I'm saying is x equals 2 and x equals 5. Now think about where that came from. This x equals 2 came from the equation x minus 2 equals 0. And then what did we have to do? We had to add 2 to both sides and to solve for x, and we ended up with x equals 2. The same way this x equals 5 came from the equation x minus 5 equals 0, because 5 minus 5 equals 0. So when we're doing this, we have to remember that these are opposites of what was in the binomial. So now I take that concept, and if my x-intercepts are 2, positive 2, and positive 5, then I know my binomials were negative 2 and negative 5. So my binomial is x minus 2, and my other binomial is x minus 5. All right, so I just went ahead and brought this up here to give myself a little more room to work. And so now we need to take this and write 3 functions, 3 quadratic functions, because they're giving us 3 different k values to use here. So it's 1 quadratic function for each k value. They all start the same way by foiling these 2 together. So x times x is x squared. X times negative 5 is negative 5x. Negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. And negative 5x and negative 2x combine to become negative 7x. So we have x squared minus 7x plus 10. So this is actually our first quadratic function with a k value of 1, because we know if you multiply by 1, nothing changes. So we have here f of x equals x squared minus 7x plus 10. So now what do we do if our k value is negative 2 or positive 3? Well, now we're going to have to take this x squared minus 7x plus 10, and we're going to have to distribute these k values. So if I take this x squared minus 7x plus 10, and now I make the k value negative 2, that means I need to distribute here. So negative 2 times x squared is negative 2x squared, and negative 2 times negative 7x is positive 14x, and negative 2 times 10 is negative 20. So this is my second quadratic function where my k value is negative 2. And then again, I need to do this where my k value is positive 3. So I'm going to end up doing the same thing here. So I have, once again, x squared minus 7x plus 10. And this time, I have to distribute a positive 3. So 3 times x squared, that is 3x squared. 3 times negative 7x, that is negative 21x. And 3 times 10, that is 30. And so there is my third function. F of x equals 3x squared minus 21x plus 30. All right, so let's take a look at our final example here. The x-intercepts are negative 3 and 4, and the k values are 1, negative 3, and 2. So first with our x-intercepts, remember the x-intercepts are opposites. Remember here we had an x-intercept of positive 2 and that became x minus 2, right? So here, if my x-intercept is negative 3, what binomial did that come from? That came from the binomial x plus 3. And if our other x-intercept is positive 4, what binomial did that come from? That came from x minus 4. And so our first step here is going to be to FOIL this out. So let's go ahead and FOIL. So first, x times x, that's x squared. Outer, x times negative 4, that's negative 4x. Inner, 3 times x, that's 3x. Last, 3 times negative 4, that's negative 12. We could combine like terms here. Negative 4x plus 3x is negative 1x. So we have x squared minus 1x, which you could also just write as negative x, minus 12. And again, our first k value is 1, so that is our first function, is f of x equals x squared minus 1x minus 12. To write our next function with a k value of negative 3, we're going to take this x squared minus 1x minus 12, and we're going to distribute. So we have here x squared minus 1x minus 12, and we have to distribute this k value of negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 1x is positive 3x. And negative 3 times negative 12 is positive 36. So that's our second function for the k value of negative 3, f of x equals negative 3x squared plus 3x plus 36. And so we have to do this one more time for the k value of 2. So we're going to say, all right, 2 times x squared minus 1x minus 12. So 2 times x squared, that is 2x squared. 2 times negative 1x, that is negative 2x. And 2 times negative 12, that is negative 24. So our third function is f of x equals 2x squared minus 2x minus 24.